Hi all, welcome to the video on week 1's post-tutorial recap after 2-hour class. And in this video, we'll be looking into more examples on average atomic mass calculation. So we have done about 2 questions in our class. So these more examples should help you understand how to do this calculation better. So let's look at this first question. This first question here is a complete question whereby all the percentage abundance of the isotopes for iron is given, as well as the isotopic masses are also given. So all you have to do is, since the question is asking you to calculate the relative atomic mass of iron, you should first start by calculating the average atomic mass of iron. Use the formula correctly. Make sure you are substituting in the correct combination of percentage abundance as well as the isotopic mass. So once you have completed the calculation, you should include the unit AMU in your answer. All right. Please take note here, there is unit U given, and this is the same as AMU. So once we have completed finding the average atomic mass, we have to now convert it to a relative atomic mass, which has the same value but no unit. So how do we do it? We take the average atomic mass divided by 1/12 of mass of carbon-12, and then there you have it. Okay, so this is one type of question. Let's move on to the next. So this next type of question is asking you to find the percentage abundance of both isotopes. So do take note over here, when we don't know a value in any question, it is very common for us to use an unknown. In this case, that is X. Since the total abundance among isotopes will be 100%, so the other isotope's abundance, we can quote it as 100 minus X. So by knowing these two, we can again key in value in our average atomic mass equation, and then we will end up getting an answer that looks like this, 50.97. If you leave the answer here, you won't be getting the full marks. So you have to answer the question. The answer is, the question is asking you what is the percentage abundance of 107 Ag, so that would be 50.97 percentage, and the percentage abundance of 109 Ag would be 100 minus 50.97 to give you 49.03. You can always pause this video and have a look through at the workings. Now for the last example, it's a bit tricky, but let's go through this. So chlorine has got two natural isotopes, chlorine 37 and chlorine 35, and these two isotopes have an abundance ratio of 3.127. Okay, and based on the scale of carbon-12, the relative masses are given specifically as these two values. Now question is asking you to calculate the relative atomic mass again. So how do we do it? In order to find the relative atomic mass, we must first find the average atomic mass. And for average atomic mass, yes, we have the me here, the isotopic mass, but we don't have the percentage abundance or the relative abundance, which is in the form of ratio. Here, I want you to understand that since this is in a fraction, it is best also the whole number here is made into a fraction. So that means what would we do? We would put over 1. So when we do that, automatically we have a relative abundance for Cl35 and a relative abundance for Cl37. And as you can see in the workings here, all right, I have multiplied the relative abundance for Cl35 with the corresponding isotopic mass, and this data over here is for Cl37, and the total key would be 3.127 plus 1.00. So when you have an abundance in ratio format whereby it is written in fractions, you can do this. Okay, you will get your final answer with a unit AMU, and since it is an average, since we are finding relative atomic mass, okay, so please write it in full, relative atomic mass. Okay, relative atomic mass of who? Chlorine. So please write that in full instead of the symbol over here, and cancel off the units, And the final answer, you have it without the unit. And that's all for this video.